Hi everyone, my name is Neha and this is the first lecture on Introduction to Automation. In this lecture, we are going to learn about the sensors. So sensors are transducers which change one form of energy into another. For example, the human body, which has an amazing sensor system that continually presents our brain with a reasonably complete picture of the environment. For example, eyes, nose, tongue, and touch. These are all senses. These sensors are used in everyday objects such as touch-sensitive elevator button, which uses a tactile sensors. These are used in lamps for dimming or brightening the light by the touch switch. In your mobile phones, you have the touchpad and that uses the sensor. In water heater, so there are multiple applications where sensors can be used, and they require an interface circuitry to mainly do this job. And most sensors, they convert some physical parameters such as temperature or position into an electrical signal to do the work. So now we are going to see one of the sensor, which is position sensor. And this position sensor is used to detect the physical position of an object with respect to a reference point. And it permits a position measurement. And it can be used to find the absolute position of a sensor or a relative position. And these position sensors, they can be linear, angular, or multi-axis. And some examples of position sensors are given over here. Capacitive transducer, LVDT, which is a linear variable differential transformer, piezoelectric transducer, Hall effect transducer, proximity sensor, potentiometer. So now we're going to see the potentiometer, which is used as a position sensor. So here you see a potentiometer sensor as a position sensor. And this potentiometer, it can be used to convert a rotary or a linear displacement to a voltage. And this potentiometer you see here, this is the real picture of a potentiometer sensor, and this is commonly known as pot also. And this pot gives resistance, and this resistance in this pot gives the value of the voltage, and we will see how we can convert the resistance into a voltage value. Now here you see a rotary pot. So this is the structure of a rotary pot, and here is the symbol of a potentiometer sensor. And where B you see it basically indicates the wiper of the resistance. And this is another type, which is a linear motion pot, and this is also kind of working as a wiper between the whole range of resistance. If we see the principle of a position sensor, it is same as a standard volume controller, but there is a difference. A pot used for a volume control, it may have a audio taper, which means the resistance it changes in a non-linear fashion to match the human perception of getting the sound. And whereas the the potentiometer sensor, it used to measure angular position, and it has a linear taper, which means the resistance linearly varies with the shaft rotation. So here you see a slider. This is a slider, or you can say this is a wiper, which slides along the resistance. This hole is the resistance material, and this resistive material could be conductive plastic and is formed in the shape of a circle. And this material has a uniform resistivity, so that the ohms per inch value along its length is constant. Now here the potentiometer sensor just described is the singleton type sensor, which actually has only about 350 degree of useful range. You can see here this is not forming a 360. There is a little bit portion which is going into these three leads, so that's why we say this will have around 350 of range. And this potentiometer sensor is similar to this one. These are the 3 leads, and rest is the range. Next, you see the linear motion potentiometer sensor, and this is another representation of a potentiometer. And you see it has A, B, and C. B is the wiper, or we can say a slider, which can go left or right direction, and A and C are the 2 terminals. And as the wiper moves, the resistance changes. This will have the resistance linearly placed, and you can measure the value of the resistance wherever this wiper stops, and corresponding to that you can measure the voltage. So now next we are going to see how we can measure the voltage. So here you see an example where the potentiometer is attached to a motor through a arm, where this arm is the center portion connecting the motor and the potentiometer, and the other end of the potentiometer is connected to a 10 volt supply, and another terminal is going to the output voltage, and the third terminal is grounded. Now this potentiometer has been represented over here, and as I told you, the range for potentiometer sensor is going to be 350. So that's what you see over here, from 0 to 350 degree, and here on the top is the 10 volts. So and at the bottom is your ground, and these you see are the wipers, basically showing the voltage at different points. So for example, if you point the wiper at this terminal, and then your voltage will be 0 volts, and if you point the wiper at the center, then your voltage is going to be half of this, which is 5 volts. And if you put the wiper all the way on the top, then your total voltage is going to be 10 volts. Now you might think why we are getting 10 volts over here and why we are getting 0 volts over here. The reason why, if you see the power supply, it moves from here to the ground potential. So if the wiper is here, then it will consume all the resistance, and therefore your voltage is going to be 0. Whereas if your wiper is over here on the top, then your power supply will go from there, and it will be gone to the output over here. So you see here how the voltage is changing evenly from 0 to 10 volts along the resistive element, and this wiper, it merely taps off the voltage drop between the contact point and the ground. And on the left hand side, we see that how this pot, it detects the angular position of the this robot arm. This arm is supposed to go up and down, and in this case the pot body is held constant, and the pot shaft, which is this, is connected directly to the motor shaft of 10 volts and is maintained across the terminal of the pot. So this is the example of how we can convert the resistance into a voltage, and now we are going to do one problem based on this. So here it says a pot is supplied with a 10 volts and is set at 64 degree. We can refer to the previous figure we saw. The range of this single turn pot is 350 degree. Now calculate output voltage. So if the pot is supplied by 10 volts, then the maximum angle we know that is going to be 350 degree. And this 350 degree, this single turn pot produces 10 volts output. And using these values, we can set up equation for ratio of output to input, and use that ratio equation to calculate the output of any input. So let's see. So pot voltage at 64 degree can be calculated by this formula: 10 volts DC divided by 350 degree angle multiplied by 64 degree. So if you use this formula, here we have taken the ratio 64 degree by 350 degree, and if you use this formula, then you will get 1.82 VDC. So this is how we calculate the pot voltage when a wiper is set at a particular angle. And so in a similar way, if the resistance is given, the total resistance of a pot is given, here the total degree is given. In place of this, total resistance is given, and if the wiper is set at a particular resistance, then corresponding to that we can find out the voltage by using the same formula. And in place of the total degree, you will have total resistance, and here you will have the set resistance value, and then you will get the corresponding voltage. So this is the end of the lecture. Thank you so much for watching.